Today I am going to present a very important distribution, that is negative binomial distribution. So, what are the topics to be covered in this today's lesson? First one is objectives, introduction, definition, moment generating function of negative binomial distribution, cumulants of negative binomial distribution, probability generating function of negative binomial distribution, recurrence relation, limiting case of the negative binomial distribution. These are the topics to be covered in today's lesson. So, now first of all we are discuss about what are the objectives of the present lesson. So, after studying this unit, you should able to define the negative binomial distribution, derive the moment generating function of negative binomial distribution, find the cumulants of a distribution, understand the difference between the negative binomial and binomial distribution. So, basically after studying this unit, you should able to define negative binomial distribution, derive its moment generating function, find cumulants of a distribution, understand the difference between the negative binomial distribution and binomial distribution. The important probability distribution is referred to as Pascal distribution after the French mathematician B.Sc. Pascal in the year 1623 to 1662, but there seems to be no historical justification. The negative binomial distribution can be derived from empirical consideration in many ways. Here we consider the binomial probability situation with some modification. Suppose we have a success of n Bernoulli trials, we assume that the trials are independent. The probability of success P in a trial remains constant from trial to trial. Let f of x comma r comma p denote the probabilities that there are x failure preceding the rth success in x plus r trials. Now, the last trial must be success whose probability is p. In the remaining, what is the remaining terms? X plus r minus 1 trials are remaining. We must have r minus 1 success whose probability is given by x plus r minus 1 c r minus 1 into p to the power of r minus 1 into q to the power of x. By compound probability theorem, p of x comma r comma p is given by the product of these two probabilities, that is x plus r minus 1 c r minus 1 into p to the power of r minus 1 into q to the power of x. P is equal to x plus r minus 1 into r minus 1 c r minus 1 into p to the power of r into q power x. So, now using above concepts, by making use of above concept, now we define the negative binomial distribution. Now, what is the definition of the negative binomial distribution? The definition of binomial distribution defined as follows: a random variable x is said to follow a negative binomial distribution of its probability mass function is given by probability of x is equal to small x, which is equal to p of x, which is represented by probability mass function is equal to x plus r minus 1 c r minus 1 into p to the power of r into q to the power of x. X takes the values 0, 1, 2, 3 and so on. Otherwise, the probability mass function is goes to 0. Therefore, once again I am repeat the definition: a random variable x is said to follow a negative binomial distribution of its probability mass function is given by p of x is equal to x plus r minus 1 c r minus 1 of p power r into q power x. Also x plus r minus 1, see r minus 1 is equal to x plus r minus 1 of x. We know the expansion forms. NCR is equal to what? NC r n minus r also, or we can write NCR is equal to NC of r minus n minus r. So we can expand these terms. Finally we can take minus 1 whole to the power of x minus r c x. Therefore p of x is also we can write in terms of negative sign, that is minus r c x p to the power of r minus q whole to the power of x. X takes the values 0, 1, 2. Otherwise p of x is goes to 0, which is the x plus 1th term in the expansion of p to the power of r 1 minus q whole to the power of minus r, a binomial expansion with negative index. Hence the distribution is known as negative binomial distribution. So why we call this distribution as a negative binomial distribution? A binomial expansion with a negative index. A binomial distribution with a negative index. Hence the distribution is known as a negative binomial distribution. So major remarks from this distribution is, just we have to remark as you know, you remember these remarks. Why? Because these are the important remarks from this distribution. In a negative binomial distribution, p of x is also referred to as, earlier all the distribution we can write p of x is equal to capital X is equal to small x like this, but here especially in this distribution we can write small f of x comma r comma p. The word negative binomial distribution is associated with the distribution because probability is given by the various terms, probability of 0, probability of 1, probability of 2 and so on, or those are the expansion of p to the power of r into 1 minus q whole to the power of minus r, which binomial distribution with negative index, hence the name is negative binomial distribution. So now next important property of binomial distribution is moment generating function. So now I am going to explain how to derive the moment generating function of negative binomial distribution. After that, how to find the mean and variance of this particular distribution. So as you know, negative binomial distribution is which type of distribution? Which is discrete distribution. Okay. So let x be a random variable, then its moment generating function is given by mx of t is equal to expectation of e to the power of tx. Moment generated is represented by mx of t is equal to expected, that is we can write in terms of expectation, mathematical expectation, that is expectation of e to the power of tx. Now summing over x is equal to 0 to infinity e to the power of tx into p of x, where p of x is equal to small x, which is known as what? Probability mass function of a negative binomial distribution, where p of x is a probability mass function of a negative binomial distribution. Since x follows p of x, then its probability mass function of negative binomial distribution is given by p of x is equal to small x minus RCx into q to the power of minus r into minus q by minus p by q whole to the power of x. X takes the values 0, 1, 2 and so on. Otherwise, this probability mass function is equal to 0. Therefore, the moment generating function of this negative binomial distribution is equal to summing over x is equal to 0 to infinity e power tx into minus r cx into q to the power of minus r into minus p by q all to the power of x. So, summing over x is equal to 0 to infinity minus r c x minus q to the power of minus r minus p e power t by q all power x. Therefore, after simplifying this expansion, we will get that only single expansion term, that is q minus p into e power t by q all to the power of minus r, which is the required moment generating function of negative binomial distribution. So, which one is the moment generating function of negative binomial distribution? mxt is equal to q minus p into e to the power of t by q all to the power of minus r is the required moment generating function of negative binomial distribution. Using the moment generating function, we can establish the moment about origin as follows. Now, we differentiate with respect to t and put t is equal to 0. If I differentiate with respect to t, we will get mean of the negative binomial distribution, that is mu 1 dash. Mu 1 dash is equal to d by dt of mx of t. So, differentiate with respect to t and put t is equal to 0, we will get first order differentiation of the first order moment of the negative binomial distribution. Using the moment generating function, we can establish the moment about origin as follows. Now, differentiate with respect to t and put t is equal to 0, we will get mu 1 dash. Mu 1 dash is equal to rp. Mu 1 dash is equal to rp. That therefore, mu 1 dash equal to rp. Therefore, mu 1 dash is nothing but what? Mean of the negative binomial distribution. Therefore, mean of the negative binomial distribution is rp, small r into capital P. We know that q minus p is equal to 1, e power 0 is equal to 1. Already you know these things. After expansion of that terms and put j is equal to 0, then we will identify the mu 1 dash, that mu 1 dash is equal to rp, small r into capital P. Therefore, the mean of the negative binomial distribution is rp. Then we can find second order moment. The second order moment is equal to mu 2 dash. That mu 2 dash means what? We can take, again we can do the differentiate with respect to t, 2 times the differentiation of moment generating function, d square by dt square of mxt, that is d by dt of mxt. If I do the differentiation, already we did this differentiation, the differentiation of first differentiation of this function is equal to r into p into e to the power of t of q minus p into e to the power of t all to the power of minus r minus 1. Put t is equal to 0. Again we can do the differentiation with respect to t. In that case, we can apply the product rule. After applying the product rule and do the differentiation of this particular function with respect to t and put t is equal to 0. So, you will get rp of q minus p all to the power of r minus 1 plus rp of minus r minus 1 of q minus p all to the power of r minus 2 of minus p. Then finally, you have to simplify these two terms. You can expand and simplify these two terms. Then finally, we can get rp plus r of r plus 1 plus p square. Therefore, mu 2 dash is equal to rp small r into capital P plus r of r plus 1 into p square. Then using this above mu 1 dash and mu 2 dash, we should find the variance. What is the variance formula? Variance is represented by mu 2. Mu 2 is equal to mu 2 dash minus mu 1 dash all to the power of 2, that is expectation of x square minus expectation of x whole square. Okay. Already you know mu 2 dash. What is the mu 2 dash? rp plus r of r plus 1 plus p square. Just now we derived that one. Then already you know mu 1 dash. Mu 1 dash is what? Mean of the negative binomial distribution. What is the mean of the negative binomial distribution? Small capital small r into capital P whole square, that is r p whole square. Then you can simplify r p plus r of r plus 1 p square minus r square p square, then r square p square will be cancelled. Here r p plus r p square is the remaining terms. Here what is the constant term here? R p is a common term taking outside of your function. Then if you can take r p is outside, then common taking out taking common 1 plus p is the remaining term. Therefore, we know that 1 plus p is equal to what? Q. Therefore, mean is equal to r p q. Already just you know that. Therefore, variance of the negative binomial distribution is what? So, therefore, variance of the negative binomial distribution is r into capital P into Q. So, what is the, therefore, you can identify these two things. First one is mean. What is the mean of the negative binomial distribution? Small r into P. Variance of the negative binomial distribution is r into P into Q. So, as Q is greater than Rp is less than Rpq, that is mean is less than variance, that is mean is less than variance, which is a distinguishing feature of this distribution. Generally, why we can this having the distinguished feature? Mean is less than variance, that is only uniqueness of this distribution. Next, cumulant of negative binomial distribution. Cumulants of negative binomial distribution. Let x be any random variable. The cumulant generating function of x is defined by kx of t is equal to kx of t is equal to log of mxt, where mxt is equal to what? Where mxt is the moment generating function of negative binomial distribution, where mxt is the moment generating function of negative binomial distribution. We know that the moment generating function of negative binomial distribution is what? mxt is equal to q minus p into e to the power of t whole to the power of minus r. Whole to the power of minus r is the moment generating function of negative binomial distribution. Therefore, cumulant of this negative binomial distribution is equal to kx of t is equal to log of this function. What is the function? mxt, that means log of q minus p into e to the power of t whole to the power of minus r. So, log this looks like a which form? Log x to the power of n form. Log x to the power of n form. What is the log x to the power of n? Also we can write n into log x. So, here instead of n you can write what? Minus r of log of q minus p into e to the power of t. So, therefore, we can find mean. Mean is equal to k1, k1 is equal to coefficient of t in kx of t, that is Rp. Mu2 is equal to coefficient of r square, coefficient of t square by 2 factorial in kx of t, that is Rpq. Similarly, we can go for mu3, that is a cumulant of k3. So, therefore, mu3 is equal to Rpq of q plus p. K4 is equal to Rp of 1 plus p of 1 plus 6p plus 6p square. Therefore, we can simplify this term Rpq of 1 plus 6pq. We know that since q minus p is equal to 1. Therefore, mu4 is equal to k4 plus 3 into k2 square. Therefore, mu4 is equal to what? In that case, Rpq of 1 plus 6 into pq plus 3 of Rpq whole to the power of 3. Therefore, mu4 is equal to Rpq of 1 plus 3 pq of r plus 2. Since p is equal to 1 by p, q is equal to p is equal to small q into capital Q, there is equal to q into 1 by p is equal to q by p. We have in terms of capital P and capital Q is also we can write in terms of small r and small p and small q also. Therefore, in that case if we can have in terms of P and Q, mean is equal to R Q by P and variance is equal to R Q by P square. Therefore, using that mu 1, mu 2, mu 4 we can find out beta 1 and beta 2 values. Therefore, mu 3 is equal to R Q of 1 plus Q all to the 1 plus Q divided by P to the power of 3, R Q of P square plus 3 Q of R plus 2 by P Q, P to the power of 3. Hence, we can find the beta 1. Therefore, beta 1 is equal to what? Mu 3 whole square divided by mu 2 whole square. Already you know mu 3 whole to the power of 2. What is the mu 2 whole to the power of 2 divided by mu 2 whole to the power of 2? Then we can simplify this, then we will get beta 1. Therefore, beta 1 is equal to 1 plus Q whole to the power of 2 divided by R Q. So, what is the beta 1 formula? So, now using the what is the beta 1 of negative binomial distribution? The beta 1 of negative binomial distribution is beta 1 is equal to 1 plus Q whole to the power of 2 divided by R Q. Beta 2 is equal to P square plus 3 Q of R plus 2 divided by R Q. By making use of this beta 1 and beta 2, we can find out the R 1 and gamma 1 and gamma 2 values. What is the gamma 1 formula? There we have a relation between beta and gamma values. Therefore, gamma 1 is equal to under root of beta 1. So, therefore, gamma 1 is equal to 1 plus Q divided by 1 plus Q divided by under root of R Q. Again similar manner we can go for gamma 2. Gamma 2 is equal to what? Gamma 2 is equal to beta 2 minus 3. What is the beta 2 value? We know that beta 2 value. What is the beta 2? P square plus 3 Q of R plus 2 divided by R Q. So, that value minus 3 is equal to P square plus 6 Q divided by R Q, that is the gamma 2 value. Now, are you clear this? Now, beta 1 is equal to 1 plus Q whole to the power of 2 by R Q, beta 2 is equal to P square plus 3 Q of R plus 2 by R Q, and gamma 1 is equal to 1 plus Q divided by under root of R Q. Gamma 2 is equal to P square plus R Q divided by R Q. Now, now I am going to discuss the next important next important property is recurrence relation for the probabilities of negative binomial distribution. So, what is the use of this recurrence relation? We can fitting of using this we can fit a negative binomial distribution, fitting of negative binomial distribution. For that, for a discrete random variable x is the probability mass function of negative binomial distribution is P of x is equal to x plus r minus 1 of x plus r minus 1 C of r minus 1 P to the power of x into q to the power of x, P to the power of r into q to the power of x, and if I put x is equal to x plus 1, that P of x becomes P of x plus 1. P of x plus 1 is equal to x plus 1 plus r minus 1 C r minus 1 whole to the power of P to the power of r, q to the power of x becomes x plus 1. Simplify this. So, x plus r, here which term is cancelled, plus 1 minus 1 will be cancelled, then it becomes x plus r C r minus 1 P to the power of r and into q to the power of x plus 1. Now, you can take P to the power of, let us assume equation number 1 and equation number 2. Equation 1 is P of x, equation 2 is P of x plus 1. So, equation 2 divided by equation 1, then I will get P of x plus 1 divided by P of x. So, P of x 1 x plus 1, P of x plus 1 divided by P of x is equal to x plus r divided by x plus 1 into q. This we can write again another form, that is therefore, P of x plus 1 is equal to x plus r divided by x plus 1 into q into q. So, comma into px, which is the required recurrence formula or relation of the relation of which distribution? Negative binomial distribution. Negative binomial distribution. So, what is the recurrence relation of the negative binomial distribution? P of x plus 1 is equal to x plus r divided by x plus 1 into q into P of x, which is the required recurrence relation of the negative binomial distribution. So, Poisson distribution has a limiting case of the negative binomial distribution. This is a very important property. What I said here? Poisson distribution has a limiting case of the negative binomial distribution. When the negative binomial distribution tends to Poisson distribution under the following conditions. First condition is the probability of a successful event P is small, that is P tends to 0. R is infinitely large, that is R tends to infinity, R tends to infinity. So, that is Rp is equal to lambda say, then the probability mass function of negative binomial distribution is given by this one. If you apply the limit, then we will go for that probability negative binomial distribution becomes changed to limit converted to e to the power of minus lambda, lambda power x by x factorial, which is the probability mass function of the Poisson distribution with parameter lambda. So, now finally we can conclude, we conclude this session today. So, which topics we are discussing? So, finally, so now again we can summarize these things. So, negative binomial distribution. So, negative binomial distribution is one of the distribution. In the distribution, using this distribution, what are the basic concepts? Why we use the negative binomial distribution is the important thing. So, that is, so the negative binomial distribution is basically mean and variance. The equality of the mean and variance is the important characteristics of this particular distribution. Always, so only all the previous distributions, what is the previous distributions like here binomial and Poisson, those distribution, and for the binomial distribution mean is always greater than the variance. If I take the Poisson distribution, both are mean and variance are equal, but here only this distribution is having shows the variance is larger than the mean. For that, if variance is larger than the mean, we can by making use of variance, we can easily estimate the things, we can draw the correct conclusion for any distribution, any distributions. Okay. So, now you know that just already we discussed which type of properties they having. So, first of all we have discussed about moment generating function of negative binomial distribution and cumulants of negative binomial distribution and recurrence relation of negative binomial distribution. These are the important topics in that who is introduced by this negative binomial distribution, that is also you have to remember. So, which distribution, who is introducing this distribution? So, a famous mathematician Blaise Pascal, but seems to be no historical justification for the negative binomial distribution. So, this distribution can derive from the empirical consideration in the many ways. So, binomial probability, here we consider the binomial situation, binomial probability distribution with some modification. Using that modification only we are getting, we are define this negative binomial distribution case. Okay. So, what is that? What is the main important things? So, important thing from this distribution is negative binomial distribution P of x is also referred by small f of x comma r comma p, So, that is only unique model, unique, hence the negative sign, the index is negative, that is why the distribution is said to be a negative binomial distribution. That is why then I can conclude this session. Thank you all.